Hi everybody, welcome back. I've just listed some homework questions here. These are for the last lecture that I posted online. They're also posted right in the description of the video, but I didn't mention them because our plan was to do more rationalizing the denominator, but we had a meeting today and we've decided to take the second part of rationalizing the denominator out of the course this semester. So that's a bit of good news for you. Okay? All right, so these are the homework questions. If you didn't see them in the description of the last video, these are the homework pages you should do. Okay? All right, good. All right, so today we're going to work on solving radical equations. And we're basically just going to jump straight into it. And I've got some more good news for you. And that is this. These are super easy to solve, so that's good news. Okay, so how are we going to solve these? So, well, to solve, we're going to do the following. Okay, one, we're going to isolate the radical. It'll be a square root or a cube root. And then two, we're going to square both sides or cube both sides depending on if it's a square root or a cube root. So I'm going to say square, cube, both sides, depending on if it's a square root or cube root. Okay, so if it's a square root, then in that case we'll square both sides. And if it's a cube root, then we'll cube both sides. And then three, we're going to solve the resulting equation. And it will just be a linear, it'll either be a linear equation or a quadratic equation. Okay, and then the last thing we're going to do is check for extraneous roots. Okay, so we're going to check to make sure our solutions work. And again, I'll explain what that means as we encounter them. Okay, so let's do an example here. All right, so for example, let's solve the square root of x plus 4 minus 1 equals 3. Okay, well, let's try doing this by inspection here. Okay, so what minus 1 equals 3? Well, if I get 4 minus 1, that will equal 3. Therefore, my answer here should be 12, right? Because 12 plus 4 is 16. Square root of 16 is 4, and that will be the desired result here. Okay, so let me show you how to solve this. Well, the first thing I want to do is just isolate the radical. Now, before I do that, let me just set up something to the side here. What if I asked you to isolate y? In this case, what would you do if you wanted to isolate y, or if I asked you to isolate y here? Well, all you would do is say to yourself, oh, well, wait a minute, I just have to, it's a linear equation, I just have to isolate y by plussing 1 to both sides, and that would give me y equals 4. Okay? All right, so if I ask you to isolate the radical here, it's going to be the exact same steps as it would be to isolate y here. All right, I've got something minus 1 equals 3. If I isolate Well, the first thing I would do is just add 1, and that would give me the square root of x plus 4 equals 3 plus 1 is 4. Okay, and now we want to get rid of the square root, and so to get rid of the square root, we just square both sides. Okay, so we're going to square. If I do that, I square the the left-hand side and the right-hand side, and that gives me that. And if you remember a square, it's the same as a power of a half. Half times 2 is 1, so these just cancel each other out like so. And that leaves me with x plus 4 equals 4 squared is 16. Okay, and now at this point, I would just subtract 4 from both sides. We have a linear equation now. Solve the equation. This is a linear equation. I'm just going to minus 4, and that gives me x equals 12. Okay, now the last thing we want to do is just check our solution, okay, to make sure it's not extraneous. So if I check, I'm just going to substitute it into the original equation. What do I have? I've got the square root of 12. I'll just substitute that in for x. 12 plus 4 minus 1 equals 3. And then 12 plus 4 is 16. Square root of 16 is 4. Minus 1 equals 3. Check. So this is a valid root. That tells me that this here is a valid root. Okay. All right, let's give this a shot again. It's a nice, easy thing to do here, I think. So it's nice to kind of, these last few topics at the end of the semester, they kind of run very nicely, and they're very useful in the next course. I'm just going to start a new page. Okay, let's work with the cube root equation. Let's solve 2 times the cube root of x plus 1 minus 4 equals 0. All right, so right off the bat, we're going to isolate the cube root. Okay, and again, just ask yourself, well, wait a minute, if I were to solve this equation, maybe I'll just do it up here. If I asked you to solve 2y minus 4 equals 0, well, it's a linear equation, so I'm essentially just asking you to isolate y. What would you do? You would just plus 4, which would give you 2y equals 4, and then you would divide both sides by 2. Which would give you y equals 2. Okay, all right, so it's exactly the same steps here. The first thing I'm going to do is plus 4, and that gives me 2 times the cube root of x plus 1 equals 4. And at this point, I would divide both sides by 2. The 2's cancel there, and there I'm just left with 4 divided by 2, which is 2. So I'm just left with the cube root of x plus 1 equals 2. And I think you can take a pretty good guess here. You probably can see x equals 7 at this point, because 7 plus 1 is 8. Cube root of 8 equals 2. But at this step, we just would cube both sides, okay, because we have a cube root. So we need to cube both sides, like so. And at that point, the cube root and the cube would cancel, and we'd just be left with x plus 1 equals 8. And then again, this is just a linear equation. So I just subtract 1 from both sides. And that gives me x equals 7. Okay, now remember, we need to check to see if this is a valid root. And I think I'll just do that in my head. Well, what do I get? 7 plus 1 is 8. The cube root of 8 is 2. So if I put 7 in here, this whole piece will evaluate to 2. And then I would multiply it by 2. 2 times 2 is 4. Minus 4 equals 0. So this is a valid root. Okay. All right. Let's try one that's a bit more difficult, and then I think you guys are pretty much ready to solve these questions. So let's try solving this one. Of course, I need to find where my original question is. Okay, let's try this one. Let's solve the square root of x plus 6 minus 1 equals x plus 3. Okay, so again, we just want to isolate the radical here. And that means plus 1 to both sides, which gives me the square root of x plus 6 equals x plus 4. Okay, and now we square both sides. Okay, now be careful here. You need to expand this out. Okay, it's not equal to x squared plus 16. You can't just apply that into the brackets. All right, this is the same as, okay, on the left-hand side, those cancel. So on the left-hand side, we're just left with x plus 6. Okay, now remember, on the right-hand side, this is equal to x plus 4 times x plus 4. I always stress to my students how this is a perfect square trinomial. You get the middle term twice, right? I get plus 4x from that, plus 4x from that. And I get the middle term twice, so this is equal to x squared plus 4x gives me plus 8x, and then 4 times 4 is plus 16. Okay, now what kind of equation is this? Well, this is a quadratic equation. And so the way to solve it is to rewrite it in standard form or general form, depending on how what your instructor calls it. So we need to set it equal to 0 or move everything to one side. I'm going to move everything to the left-hand side here. I'm going to minus x minus 6 minus x minus 6, and that leaves me with 0 equals x squared 8x minus x is plus 7x. 16 minus 6 is plus 10. And now we need to factor this and use the zero product property. So I'm looking for something that multiplies to 10, and it needs to add to 7, and 5 and 2 work. Okay, so we can use the decomposition, or we can just write 0 equals x plus 5 times x plus 2. Okay, and then applying the zero product property, we need to set this factor to 0, which gives us x equals minus 5. And we need to set this factor to 0, which gives us x equals minus 2. Okay, now we're not quite done yet. We should check for extraneous roots. Okay, so I'm going to check x equals minus 2 first. I'm just going to substitute it back into the original equation. And if I do that, I get the square root of minus 2 plus 6 minus 1 equals minus 2 plus 3. And then this here gives me the square root of 4. Minus 1 equals minus 2 plus 3, which is 1. And hopefully at this point you can see that this is true. So you'd end up with 2 minus 1 equals 1. So this is a valid root. That's a valid root. Okay, now if we check x equals minus 5, what do I get? I get the square root of minus 5 plus 6 minus 1 equals minus 5 plus 3. And this just gives me the square root of 1 minus 1 equals minus 5 plus 3 is minus 2. And what do we get? 1 minus 1 is 0 equals minus 2. No, that's not true. That's not true. Therefore, this is an extraneous root. And sometimes we get extra solutions that don't work with the original equation. Okay. All right, so I think that's it for this video. Yeah, these ones aren't too bad, I think. As long as you can solve a quadratic equation, you should be really okay with this. You should feel really comfortable with this. Okay? All right, let me give you guys some homework questions. So for homework, okay, avoid the questions with 2 radicals in them. We don't need to do those. But you won't find any of those on these pages that I'm about to list for you. Okay, so for homework, you should do 382 to 383. And then you should do pages 385 to 386. Okay, if you do run into one where there's more than one radical in it, there might be one on this page. I don't think so. But if you do, don't worry. You don't need to be able to solve those. You can always give it a shot. They're not too bad. Just work your way through the example first and then give it a shot. But you're not responsible for them this semester. Okay? Excellent. Okay, guys, have a great day, and I will see you for the next video, which will be trigonometry, so that you guys can do your trigonometry tutorials.